Assalamu alaikum, guys. Another day, another dollar. Today we're gonna go through chapters 4, 5, 6, practice problems for applied mechanics, statics. Hope y'all's day is going good, going well. Mine's pretty good. But yeah, let's get started. Question 1 is asking us determine the reactions at A and B. So we're gonna draw, let me see, I'm gonna draw the little arrows, right? I'm gonna explain. Every single joint has a little reaction to it, right? Like for example, this is hold on, let me get the cursor out. This one right here is a pin joint. So it has a X and Y reaction. And this is a roller joint right here. So this is gonna be just what's it called? A Y reaction. And a way you can think about this is like, think about what it can't do, right? Like for example, right here, this can't go into it. This can't go into the ground, right? But it can go left and right if it wanted to. I mean, obviously there's a pin here, but if there was no pin, it could go left or right, right? So that's how you think about it. It can't go like into the surface. So you'd put an opposite reaction. And for this one, it has an X and Y, right? X and Y reaction, because it can't go left and right and it can't go up and down. So that's why you would put that. But yeah, so they want us to determine the reaction. We're gonna start with finding moment about A. That's gonna be R cross F, and R is just the distance from A to the force, right? The force is, like for example, here's 6 meters, and for this it's gonna be 10 meters. So if we want to find that moment about A, it's gonna be 6 times 4 kilonewtons. And we have to determine if it's positive or negative. So let me see. This is going to be going counterclockwise. No, clockwise. Okay, so this is negative right here. This is going to be negative, and this right here is going to be positive. So because it's counterclockwise. So let me see. By times 10. Right, times 10. Oh yeah, this is equal 0. So you have to set it equal to 0. And then that will give you the by. That'll give us that by is 2.4. So by equals 2.4. And then with that, we can get ay. And ax is going to be nothing because, like, if we do sigma fx equals 0, there's only one x, so it's, that's 0. And then so yeah, I'll just delete that anyways. We're gonna do sigma fy equals 0. And if any of you don't like understand something, feel free to just like put in the comments or something like that, or maybe the group chat. I'll definitely get back to you. Anyways, sigma fy, we know that by is 2.4, so we're gonna do 2.4 plus a y. You can just put a equals 0, and then with that we're gonna get, oh wait, my bad, I forgot to put minus 4 because it's minus direction, equals 0. And with that we're gonna get ay, let's see, ay equals 1.6 kilonewtons. Okay, this question. 2 crates of each of mass 350 kilograms are placed as shown in the bed of a 1,400 kilogram pickup truck. Determine the reactions at each of the 2 rear wheels and the 2 front wheels. So in this case, let me see. I'm writing here. So what does the professor always say? Start with the free body diagram. In this case, I'm gonna just like use the truck, I guess, as the rigid body. So yeah, let's draw the reactions. The axles are like a pin, so we would do, x and y. They're nice enough to give us the center of gravity, so that's that. It's 1,400 kilograms, so we just do 1,400 times. Yeah, forgot where we left off. We're trying to find reactions at A and B. You're just gonna find like moment, and with moment you'll find this. This one's kind of like the other one, so I'm gonna skip it. You know, like there's nothing to learn here except for like, okay, if you have 1,400 kilograms, you just do that and then times 9.8, and like a lot of this is practice, so make sure you guys, you know, do that, like practice this stuff. Times 9.8, and then that'll give you whatever newtons. Maximum allowable value of each of the reactions is 180 newtons. Neglect the weight of the beam. Determine the range of the distance for which the beam is safe. So in this one, what we need to do is first draw the reactions. So it's a roller. This is a pin, and we need to find the range, like where D is basically where it's safe for the beam to be, or for A to be. I mean, like imagine this can roll. This can roll like that way, like this way and that way. Obviously, it can't exceed this, but so yeah, we're gonna find moment about B to solve this. So moment about B equals 0, and this is gonna be equal to, let me see, 100 times, let me see, this is negative? No, it's positive. So it's gonna be 100 times 0.45, because we're gonna put in meters. 0.45, and then wait, is that meters even? Yeah, that's meters. And then let me see, and then you're gonna do 50 plus 50 times 9, 0.9, right? Because these are both positive, they're going in the counterclockwise direction. And then minus A times D is like all of this, and then the distance between it, so it's going to be 0.9 minus D equals 0. And then what we're going to do is put this into, like, solve this. It's going to give us, I think, wait, it's going to give us 90 Newton meters, minus A, 0.9 minus D equals 0. We're just going to move this to the other side. It's going to be 90 equals A, 0.9 minus D. And we're going to divide this to get it to that side, and that's going to give us A equals 90 over 0.9 minus D. And then we know A can't be more than 180. So we're going to set this less than or equal to 180. And then that's going to give us, hold up. So yeah, now we're saying that A, like the reaction at A, has to be less than or equal to 180. And if we go ahead and solve this out, I'm gonna divide by 180 on both sides, and then what's it called? And then multiply 0.9 minus D to that side, and that's gonna give us, I think, 0.5 less than or equal to 0.9 minus D. And if we move that over, it's gonna give us minus 0.4 equals minus D. So therefore, D is greater than or equal to 0.4. So that's what we got for moment about B. And we're gonna go ahead and do moment about A, and that should give us a different answer. So hold up, let me just So now we know that D is like greater than that. So I'm just gonna erase this. Let's see. D is greater than or equal to 0.4 meters or 400 millimeters, as we can see in the answer here. So now we're gonna do moment about A. Let's see, moment about A is equal to 0, equal to, let me see, 50. It's gonna be 50D, 50D minus, because that's the minus direction, minus 100, let me see, minus 100, 0.45 minus D, and then we're gonna do 150. 150 is gonna be, let me see, that's negative, minus 150, 0.9 minus D, and then plus by right here, plus by times 0.9 minus D. And then if we combine this all together, it should give us, let me see, 300D minus 180 plus by. We just want to simplify it. 0.9 minus D. And if y'all didn't get that, I just like expanded these and then combined like terms. It's gonna be equal to 0. And what we're gonna do is we're gonna take all of these to that side and then basically like isolate by. So this is gonna be 180 minus 300D D over 0.9 minus D, and then that's gonna be equal to by, and this whole thing's gonna be less than or equal to 180. And then so now we have this is less than or equal to 180D. I'm gonna multiply this on both sides and put it there, and that should give us 162. Let me see, 180 minus 300D less than or equal to 162 minus, what was it, 180D. And then we're just gonna combine, like, I'm gonna move this to that side, put the D's together. And then that's gonna give us 18 is less than or equal to, what was it, 120D. And then we're just gonna divide this, and that should give us D greater than or equal to, no, let me just keep it on the same side. I'll do like this, 18 over 120 less than or equal to D. And I think that's, let's see, 18, 0.15 meters. So this is gonna be 0.15 less than or equal to D and 0.4. So that's how we get our answer right here. This is meters, so that's why it's millimeters here. There's just this question left that I think y'all should know for chapter 4. But I'm gonna put a video in the description that's gonna like explain it perfectly, because I need to make more time for the other chapters, inshallah. But yeah. Chapter 5, centroids. So for centroids, what it basically is it's like the center of gravity of the shape. So it's gonna be like, you know, somewhere there. Or we're also gonna do like 3D. Let me see. So let me see. What you're gonna want to do first is separate it into different like basic shapes. For example, a triangle and a rectangle. Same thing here, triangle, rectangle. I'll get into that one later. This one you can do like triangle, triangle, rectangle, and this is just a rectangle with a cutout of a half circle. But you get the basic idea. To make it easy on yourself, you're gonna wanna draw a little, what's it called, chart. We're gonna say, so this one has two shapes, so we'll call it shape 1. This one's shape 2. We're gonna do a little chart like this. A x component, y component, right? And then we're gonna do 1, 2. We're gonna find the area of shape 1, the x component of shape 1, y component of shape 1, and then same thing on the bottom. And then I'll show you later. So for in our case, area of shape 1 is gonna be 1/2 base times height, times height, and that's gonna be 1/2 base. We could call this base, actually. It doesn't matter. It's a right triangle. So this is 160 times 80. Times 80. That's gonna give us 64,000. Make this bigger. It's gonna be 64,000. And then for shape 2, it's a rectangle, so just base times height. 28,800. 28,000. That's for the, what's it called? The area. And then for the x component, you're gonna want to find like the middle, or it's like an x component. Like for example, for a triangle, it's gonna be 1/3, right? 1/3 from the right angle. So like for example, this is 160. So 160 divided by 3 is gonna be 53, approximately. But it's gonna be 53 from here. And let's say we calculate this, it's gonna be whatever from here, right? So in our case, since it's 53 for the x component, we're gonna do 80 plus 160. 160, that's 240 minus 53, right? Minus 53, that gives us 187. So our x component is 187. And then for our y component, or you know what, let's do it for this one first. It's gonna be divided by 2, obviously, because it's like we're trying to find the middle pretty much. 260. And then we want the y component. Let's see. The y component, it's gonna be 80 divided by 3, and then you add this to it because it's from the origin. This is approximately 27, so 120 plus 27 plus 27, that's gonna be 147. I'm gonna call that 147. And then for the y component of this, it's gonna be 60. And then you're gonna multiply this by its area, like the x component by its area, and that's gonna be ax, right? Let me see, ax. And in our case, it's gonna be 1,196,800. And then this is gonna be 7,488,000. We can simplify this. Whatever. I'm gonna just keep it for now. And then ay, right? A times y. It's gonna be this times that. 940,800. And this is gonna be 1,720,000. 728,000. And then you're gonna have a bottom section here called, we're gonna call it sum. It is called sum. and you're just gonna add this to that, and it's gonna be 64. You're gonna add these all together pretty much, this with this, except for the components, like these don't. So this plus that, and then this plus that, and this plus that, and you're gonna put them under each thing. So 64,000 plus 28,800, it's gonna be 35,200. This one's gonna be 8,684,800, right? 800. And then this, it's too big of a number. I'm gonna say 1.6 times 10 to the power of 11. And then to find the centroid, it's gonna be and then to find the x coordinate of the centroid, it's gonna be, so we'll call it xc. It's gonna be sum of x coordinate times a over sum of a, and then let me see, y coordinate is gonna be the same, sum of ya over sum a, and then if we, well, I'm gonna do this on the side, you'd get 86 or 8,684 divided by, and that's approximately 247 for the x coordinate, so this way. And then for this one, it's gonna be 1.6 times 10 power of 11 over that 35,200. Dang, wait, I need to make a correction here. This is actually 2,000, or wait, 2,000,000 688,800. Damn, wait, I actually made a lot of mistakes. So this is gonna be 200 and, no wait, 120, my bad. It's gonna be 120. But you guys get the idea. It's like, let me see. It's gonna be 3,000,000. And then if we were to plug that here, let me see, wait, we're gonna have to correct this now. And then if we were to plug this into here, because that number doesn't even make sense to begin with, it's gonna give us, let me see, approximately 132. So, and then if we get this, let me see. We gotta correct this too. It's gonna be 800, and that's gonna give us 75, approximately 76. And then that's how you find that. But for the rest of these, I'm gonna link another video in the description, because, you know, time's sake. But yeah. And oh, I forgot to explain this part. For this one, you're gonna do basically the area of this area under this. So it's 200 pounds per feet. There's 4 feet, so you're gonna do 200 times 4. That's for the rectangular ones. And if there's these triangular ones, you're gonna do, you know, it's like 1/2 base times height. So that's gonna be 1/2 of 150 times 3. You see, and there's also gonna be some let me see, some weird ones that you might see. It looks like this, and there's a, what was it? I think it was like this, and it was like a little square, right? You can separate those into different sections. Same thing. And there's one more. It was on the quiz, but that's pretty much it for centroids. Just watch the video in the description. It should clear things up, inshallah. So we finally arrived, chapter 6. We've all been waiting for. This one. So what you're gonna do here is, so this is a rocker. This is just, normal force. This is here and here. And then what you're gonna do is you're gonna get each of these members right here and draw the free body diagram. And you're gonna assume whether this is being pulled or like compressed. And in this case, I'm gonna assume it's getting pulled. So, what's it called? From here, I'm gonna assume it's like this way. That's my assumption. And then this one, I'm gonna assume is this way. And this is our point, and this is 5 kilonewtons. And this is BC. This is was that A? Yeah. AC. And this is a 45 degrees because this is 1 meter right here. 1 meter and 1 meter. That's gotta be 45 degrees. And we're just gonna find sigma F y, right? Sigma Fy, and there's no Fy on this one, so we're just gonna do this. It's gonna be equals 0, -5 kilonewtons. I'll just write it, kilonewtons, plus what's it called? Sine of BC. BC sine 45. BC sine 45. And in this case, we got that BC is positive 7 kilonewtons approximately. And if it's positive, that means our assumption is true. And if it's negative, like let's say we got negative kilonewtons, you just like flip the arrow pretty much. But we got the correct assumption, so 7 kilonewtons. And we're gonna find sigma Fx. And let me see, sigma Fx. We're gonna do minus AB, right? This thing right here, minus AB plus plus the like positive of this, and we know that BC is 7 kilonewtons, so plus 7. Let me see, 7. Looking for, what is that? Adjacent, yeah. Cosine 45. That's gonna give us the AB. AB is 9, or no, AB is 5, so 5 kilonewtons, and it's equal to 0. Just don't forget that. AB is equal to 5, so our 5 kilonewtons. Our assumption is also true here, so it's positive. And that's basically it for like chapter 6. I don't know if there's anything I could add. It's like, and you'd basically like take these, right? This is AC. We know this now. We can get these two, and it's like, it's a lot of practice. That's all it really is. I don't know if there's any more that I could explain. Let me check. This probably like zero members. We did that today. It was like, he cut this. So 0 member is basically like, if there's a straight part here, right, and there's no force, like let's say for example, I'll explain that later, but if there's a straight here and there's only one member, right, only one member, like let's say we were to cut this, it would look like this, right, or like this, since it's upside down. It's only one member, and if we were to do sigma Fy is equal to 0, it would be like the only thing that's y, so it's, so it's zero. That's why they call them zero members. And then there was one more thing. It's like, okay, right here, for example, this one, this is like that, but you have to like remember that there's a force coming this way, so this is not a zero member. And then if there's a zero member, let's say like this is a zero member, this is cut, so that makes this now a zero member, since it's like if you cut it and this doesn't exist, this is now a zero member. And then you can do the same from here, just cut, and that would make this a zero member. But yeah, that's pretty much it for chapter 6.